Yes. So this is 3x minus 1 squared equals 75. This is a quadratic equation, and what is the method that is the best here? Say it again. What is the method of those four methods? We have quadratic formula, factoring, taking square roots, and completing the square. Which of the methods is the best to apply now? Of course, it's already set up. So this is 3x minus 1 equals plus or minus. Remember, this is 3 times 25. So this is 5 the square root of 3. Therefore, we will have to add 1 and divide everything by 3. So 3x equals 1 plus or minus 5 the square root of 3, and x equals 1 plus or minus 5 the square root of 3 over 3. Very good question. Next question, please. Which one? Let's look at number 10. Number 10. I don't think we did number 10. Let's take a look. X squared plus y squared minus 2x plus 4y minus 9 equals negative 5. So we are asked to show whether this is the equation of a circle. In other words, if you remember, the equation of the circle is x minus h everything squared plus y minus k everything squared equals r squared. If I manage to show that this can be presented like this, then it represents the equation of a circle. And of course, the right-hand side cannot be 0 or a negative number. This cannot be negative, right? So if all set up, if everything works like this, then I'll conclude it's the equation of a circle. Okay, so then what do we need to do? What is the idea? The idea is to, what is this? And what is this? Say it again. Well, I can't really, but what you're saying, I'm assuming, is that to complete the square. That's what we have to do. So we have to complete the square with x. Good. Yes, that's what I thought. So then what do I have to add to both sides in order to complete the square? X squared minus 2x. And let me refresh your memory. This was three and a half months ago with our very first handout. That's how we started the class. 3.5 months ago. So what do I need to add to x squared minus 2x? And I have to add it to both sides in order to complete the square with x. So I need a third term. Exactly. Yes, we have to add 1 to both sides because x squared minus 2x plus 1, these three terms will make up the binomial squared. Which binomial squared is x squared minus 2x plus 1? Excellent. Well done. X minus 1. Very good. That's what we did 3.5 months ago. Why? Because it pops up almost every class. We can't get away from it. Okay, now in the same way, we will have to complete the square for y squared and 4y. Y squared and 4y. What does that need to both sides? You're on the right track, but think in terms of the fact that you have to square it before you put it in. The 2 is correct, but it has to be squared. Squared. Which is correct. This plus this plus this will form another square, perfect square. What do I need here to get y squared plus 4y plus 4? Exactly. Awesome. Very good. So now what did I use and what I didn't? So here's what I did not use yet. I did not use this, I did not use this, I did not use this, and I did not use this yet. Everything else was used. But you see, these three go away. because 1 plus 4 is 5 and minus 5 is 0. So the only thing I need to do is put 9 to the other side, move it to the other side. It was negative on the left. It's going to be positive on the right. Okay, so now does this represent a circle? And the answer is yes. And we have to identify the center and we have to identify the radius. We may also be asked to graph it. So what is the center? Yes? So obviously we have to compare these two and identify age. And we have to compare these two and identify k correctly. Very good. And the radius is? Very good.
Why is it? Oh, just kidding.
So now do we know how to graph this in case we need to graph it? Do we know how to graph it? Do we have to graph it now?
No. It doesn't tell us to.
Right, but just in case, do we want to graph it or not?
No.
No. Okay. Good. Yes? Stephen, do you want me to help you with that? No. Okay. Yes. Yes. Yes, I know. This is the only class you missed. And you tortured me in September, and then in October, and then in November, and now we're in December. Yes? How would you get 4, right?
No, 9.
It wasn't the problem. I had no choice. It wasn't the problem. It was negative 9.
What about the 5?
I'm sorry?
What about the minus 5 on that side?
It wasn't the problem. Negative 9 and negative 5 were in the problem. I just copied them. Oh, you're asking why we didn't move 9 to the other side from the beginning? Because it's not my focus. Numbers can wait. My focus is x and my focus is y. And the numbers can wait. If you want to move 9 from the very beginning, you can. But that's not my focus. I don't care about 9. I care about completing the square with x and completing the square with y. 9 can wait. Does that answer your question or not?
No.
Okay, what is the question again?
I see you adding plus 1 and plus 4.
Correct.
Adding or subtracting?
Okay, so the problem is not negative 9 anymore, correct? No. Okay, we solved the problem with negative 9?
We'll move 9 on the other side.
Okay, so that's okay. That's clear. Okay, so now the question is, how do we get 1 and 4?
Okay.
Okay. So that's how we got the 1.
I get that.
So that's how we got 4. But I cannot add it just to one side. I have to add it to both sides. I'm not allowed to add to one side of an equation and not add to the other. So see, the balance is this: 1 pound to 1 pound. And then I will just put 3 more pounds in one. Is there a balance? Not anymore. I have to put 3 pounds on both sides.
So now you're moving plus 5 on that side and the cancels out.
The 5 was already there. I didn't move the negative 5 anywhere. I only added 1 to both sides and 4 to both sides. These are 0. And then I moved negative 9 and it became 9. Better? Okay, very good. Good. Let's look at the next question. Anything else?
8.
8. 8, 8, 8. 8. Okay, very good. Which one? Which one in number 8?
Let's go with the first one.
The first one, very good. And we have f of x, 2 times x minus 2 over x minus 2 and x minus 1. That's what I have to do immediately with any function like this one, rational. I have to simplify. I have to factor completely so I can find the domain and the x and y intercept, etc., etc. Good. So can anyone give us the domain of this function? Or basically, what I'm really asking first is what x cannot be. That's the first question. So 2 and 1. Only now I can simplify. And I get 2 over x minus 1. Not before I state restrictions. That's mandatory. Okay.
So what is the domain?
Can anyone give us the domain, please? To. Very good. Union. You cannot jump. There are infinitely many numbers between 1 and 2, right?
Yeah, 1 and 2.
Union 1 comma 2. Union. Excellent. So negative 1, 0, 1, 2, infinity, undefined, undefined. Good. So what type of function is it, by the way? Very good. Fraction and x in the denominator. Awesome. Is it type 1, type 2, or type 3? Yes, because the degree in the denominator is higher than the degree in the numerator. Awesome. What is the horizontal asymptote for any type 2? Always, forever. Exactly. Awesome. So 0, 0, y equals 0, horizontal asymptote. Excellent. For type 2, the horizontal asymptote is always 0. Very good. So what can you say about x equals 2? And what can you say about x equals 1? Yes, but something happens there in both situations. What happens? Crosses and turns are only for the x-intercepts, not when the function is undefined. So the multiplicities are only for x-intercepts.
No.
Yes, which one? Awesome. Which one? No. Very good. So that's a good point. One of them is a vertical asymptote and the other one is a hole. Which one is a hole and which one is the horizontal asymptote? See, one of the factors disappears, is no longer left in the denominator. The other one stays. So then which one will be a vertical asymptote and which one will be a hole? Nope. If it stays and I can plug it in, it's a vertical asymptote. If it goes away, it's a hole. So if the factor in the denominator is x minus 1, x equals 1 will always be a vertical asymptote. And if the factor that goes away is no longer there, right? It goes away, so it's a hole. Good. So now please, can we turn that off? Okay, so let's plug in 0, and please tell me what you get. When we plug in 0, we get? Very good, I agree. When we plug in 2, what do we get? 2, very good. And now when we plug in 0.9 and we plug in 1.1 for the sign of infinities. So this is a VA, so we know that left and right we have infinities. But we don't know what the sign is. So let's plug in 0.9 and just give me the sign of this infinity. Nothing else, just the sign. Negative indeed, because 0.9 minus 1 is negative, the top is positive. On the other side, very good. That's all we need. When I graph a function with asymptotes, what do I have to graph first? Indeed. One is just an overkill, y equals 0. The other one is x equals 1. I have to plot 0, negative 2. I have to plot 2, 2. And now I'm ready to graph the function. From 0, it crosses the y-axis, and it goes to negative infinity. From approaching 0, crossing the y-axis, and approaching negative infinity. It will never cross a vertical asymptote. Then on the other side, from positive infinity, is going through this point and approaching 0. So this is the graph of f of x, 2x minus 4 divided by x squared minus 3x plus 2. Only now you can go to the graphing calculator and check and make sure that everything is okay. However, the graphing calculator will not show you that point.
You doing it or are we moving on?
Okay, whatever you want. Any questions on this? Any questions on this? Yes? Anyone? Okay, we want to go to 12 and then we'll come back to other problems. We want to jump to 12. Okay, we want A, B, whatever we want. Which one?
A.
Very good. So we have log x plus log x plus 15 equals 2.
So this is 12.
Yes. Very good. So what type of equation is it? Obviously it's an equation, but what type is it? If you read it, it is a log equation. Once you say log, it must be good. So now if you remember, log is not a friendly function. It's not defined everywhere. So therefore, we have to state a restriction for this. What will you say? For this log x to exist, I have to write something that gives us a domain of this function. What do I have to write? Say it again. No, because log it cannot be applied to 0. Say it again. No. How do we find the domain of a log function? What do we have to write to find the domain of a log function? What is the domain of log? Which values or x values I can plug in log? Perfect. So then x must be greater than 0. For this one, what do I have to write? Very good, indeed. So now the common domain will be given by both conditions. And please give me the common domain. Very good. Well done. So you can graph it, right? So negative 15 to 0, 0, a negative 15 to positive infinity, and 0 to infinity. I need both at the same time. Of course. Very good. Or you can graph it, right? So if I don't get solution or solutions that are strictly positive, not even 0, then I will disregard them. Very good. So then what is the next step here? What do we have to do with this? Perfect. How do I condense the left-hand side? Thank you, Reggie. Yes, so what do I write? Very good. Equals? Good. So now this is equivalent to, and some of you wrote 0. So please don't do that. Good. So now what do I have to write? How do I change this log equation to an exponential equation? What is the base? Very good. Awesome. That's where I have to start. I start with the base. So then 10. Very good. 10 squared equals x squared plus 15x. So now I was expecting an exponential equation, but it collapsed into a quadratic, which I know I have to set equal to 0. What now? I have 4 methods. Use one and give the solutions. Very good. And very good. So then we have x equals negative 20 and x equals 5. And I'll say, wait a minute, and draw a conclusion. And the conclusion is clearly what?
They're both true.
Really?
Oh, negative 20. No, that one doesn't work.
Very good. So please remember, this is our last day of classes. We do not meet on Monday.
That's one.
Monday is final exams. All next week is all the final exams. This is our last meeting. And we meet again on Saturday if you'd like.
Wednesday.
The final exam week starts on Monday. Today is the last day of classes for us. And we meet again on Wednesday. Good. Next question.
B.
B. Very good. One third raised to x minus 2 equals 9 raised to 2x plus 3. Very good. What type of equation is this? Very good. It's an exponential equation. I prefer and I really hope that both sides can be presented with the same base. So can they be presented with the same base? So the right-hand side is the easy one. So what will I have instead of 9? That's the only thing. There is nothing else. So I'm hoping that the left-hand side can be presented with the base, the same base. Very good. 3 raised to negative 1. Everything. Oops. Sorry, I'm going to delete that. I meant to write x minus 2. Good. Now I need one intermediate step before I make a conclusion, or I draw a conclusion. So what is the next step? I copy the base. What happens to the exponents? Yes, multiply. What do I get? Very good. Awesome. Copy the base. 2. So it's 4x plus 6. Good. So because the exponential function is 1 to 1, if two numbers are equal and they have the same base, what must happen? I agree. Very good. Awesome. That's the answer. So I will move 4x, and I get negative 5x. I will move 2, and I get 4, so x equals negative 4/5. Do I have to check? No, unless you want to. How come that I have to check with logs and not with exponentials? Because exponential function is defined everywhere. Friendly function. Log is not. That's why we had to state a domain or go back and check. Next question, please.
13.
Okay, let's take a look at 13.